and welcome. I'm Dave. Today we'll learn about TypeScript type aliases, functions, literal types, and the never type. I'll provide links to example source code and all resources in the description below. Today's starter code is our code from lesson 3, and we're going to use just a little bit of this code. So I'm going to scroll down to about line 38, and you can see I have the interfaced guitarist highlighted that we created in lesson 3. I'm going to use Control X to cut that out, and then Control A to select the rest of the code and just press backspace to delete it. Now I'll paste this interface back in. And if you remember from the previous lesson, before we created this interface, we used the keyword type. And then of course we had to have an equal sign over here as well to represent this object. What we're creating is called a type alias, but this can apply to more than just objects. So I'm going to comment that up here. Type aliases is what we're going to discuss. And let's create another type alias. So I'll say type, and then I'm going to say string or number. And we can set this equal to a union type that is string or number. And now, instead of having to type out the union type string or number, if we were using this in several places in our application, we could just use this string or number type. Likewise, we could add more to the union type, or we could just define another type if we want to. So let's do another one here, and let's say type string or number array. And let's go ahead and set this equal to what we see in the guitarist below. So now we have string or number, and it's also an array. And now that we've done that, we can actually use this type inside of our guitarist object that we created. So we're using a type alias inside of another type alias, and this works as well. Or let's say we have a type that is a user ID, and it could be a string or number as well, and we've already defined the string or number type alias above, so we could just set this equal to string or number, and this would also work because now type user ID is going to be a string or number union, just like the string or number type that we assigned above. So essentially, we are representing our TypeScript types with a different name, and that is what is called an alias. So we are creating type aliases for our TypeScript types. Now again, if you have the question in your mind about why is a type different than an interface, we cannot do this with an interface. So here I'll say post ID and try to set this equal to string or number, and that just won't work. So interfaces, think about those more as objects or classes, if you will, and types you can think of as an alias for any type of TypeScript type that we might assign. Now let's look at literal types. I'll comment that right here, a literal type or types, and I'll assign, say, let my name, and I'm going to assign it my actual name instead of saying string, number, or Boolean, for example, or a union type of any of those. And now when I mouse over, let's look at the IntelliSense, and it says, let my name, or my name is type Dave. Now that's different than what we've seen before. So that is a specific assignment. It's a literal assignment. So if I try to set my name equal to John, TypeScript does not like that. So instead of setting my name equal to John, I can only set it equal to my name, which is Dave. But we might want to have a variable that would be a little bit more useful than that. So let's say let username, and then we'll use a union type here with literal assignment. So we could say Dave or John or Amy, for example. Now any of those values would be valid for username. So we could set username, and then we could set it equal to, and notice we get IntelliSense to help us out now, built into TypeScript as well. So it could be Amy, Dave, or John here inside of Visual Studio Code. So we'll just assign Amy, and that is a valid value. But any other name in there, say Rachel, nope, it doesn't like that. So it can only be Dave, John, or Amy. So once again, when I type the single quote, we get IntelliSense help, and I'll assign Amy. So a literal type with only one value is much like saying const my name equals Dave, because that would not be reassignable. And in this example, the only possible value is my name, which is Dave, for the myname variable. However, these can be very useful when you use the union type, because now more than one value can be assigned, and you might have a variable where only certain values are expected. And you could do this with numbers as well. So literal types can be very useful, as well as keeping your code dry, because you might assign this once to username and then use username in your code, and you'll know it only expects these three values without specifying these every time. And really, you could go back to the aliases and say they could also keep your code dry, because you're creating a type instead of possibly a somewhat long type definition with a union or something like that. This is fairly short, but instead of typing this every time, of course, you now have the type alias you can refer to. So a benefit of both literal types and type aliases could be keeping your code just a little drier. And of course, dry means don't repeat yourself. It's that acronym DRY. Now let's look at functions. So I'm going to return, and I'll put functions here. This is a bit of a review because we looked at a function called sum in previous lessons, and this will be a review of that. I'll just call it add instead, but basically the same thing, where we could have two variables, a and b, and then we'll have an arrow function here for this example. Then I'm just going to return a plus b. Now we've already learned that TypeScript can infer what these are, but you can see TypeScript does not like what we have here. We've got a line underneath. Parameter A implicitly has any type, and we'll see the same for B. So we have not put those types in explicitly, and TypeScript would really like us to do that. So let's go ahead and say both of these need to be number types, and we could provide a space there as well. And here I'll put number also, and we don't need a space there after the type. So just formatting a little. So A and B are number type. But notice when I mouse over the function name, add, it also says it returns a number. So it is still inferring what this function would return. So we can supply that information as well by putting a colon right after the parentheses and putting the type of data that the function will return. Now, one thing we have not looked at is a function that does not have a return. So let's create that, and I'll call this log message. And this is going to accept a message, and we'll assign the any type, because we could be sending any type of data here that we want to log. And then afterwards, well, I'm not going to say what type it is. We'll let it infer, and then we'll go ahead and assign it after. So we're just going to console log whatever message we send in, and it can be any data type. Now let's mouse over log message, and we can see the return type is void because it does not have a return. So if we were to assign that, we would do it in the same way. We just say void, and this void type is for functions that do not return anything. So this is a side effect. Any function that would have a side effect that would not have an explicit return should be a void type of return data, which essentially means there's no return at all. So let's use our log message, and we'll call that, and we could pass in hello, and TypeScript is fine with that. I'm going to do Shift, Alt, and the down arrow to copy it a couple of times. We could also pass in our add function. Say we're going to add 2 and 3, and our add function is fine with that because those are two numbers passed in. Let's once again do our add function. Now let's pass in the string A and 3. I'll get rid of that extra single quote there. And it does not like that at all. I need the extra parentheses there too. So now we've got log message twice. Oh, and I've got double and single quotes. So no wonder it didn't like all of that. Here, now we just have the error I expected, which is saying that the argument type string is not assignable to the parameter type of number. And we're getting that because that's our add function. So we're passing in data that will not work with that. So if we change this back to numbers like above, it would be fine. I just wanted to show that example to show that it still works inside, even when we're calling a function inside or passing this in to another function. I'm going to go ahead and save this data. Then I'm going to do Control backtick to open up a terminal window. Type tsc-w so it starts watching our TypeScript files and creates the JavaScript files. We have learned how to set that up back in lesson 1. Now that TypeScript is running, let's go ahead and drag this over to the left. I've got an empty browser here to the right. I need to go into the build folder, click my index.html, click Go Live to launch Live Server. So we run our code, and now we should get this black background instead of the somewhat charcoal background I had in the other tab. And I'm going to Control Shift and I to open up DevTools just so we can see our console log statements. I'll also do, I'll select the main TS file that we're working in and then Control B to hide the file tree so we can see our code here on the right. But now we see our log messages. Besides the live reload enabled from live server, we get hello and the number 5. Okay, I used arrow functions both for the add function and the log message function, but you do not have to use arrow functions. So I'm going to scroll up and create another function, and we'll call this one subtract. So I'll say let subtract. It's going to equal a function. I'm going to use the function keyword, and then I'll give C as a parameter, and it's also a number, and D, which is also a number. And this is also going to return a number. We could have curly braces here. I'll press Alt-Z to wrap the code down just so we don't miss anything. And now we need to return C minus D. Now that we've completed the function, TypeScript is happy, no error marks here. And just note that this is wrapping down a line since I have the browser open on the right now. And this is the return type here, the number as well, just following the parentheses, just like we had above for add. We're just taking up a little bit more room because we have a larger word here for subtract and we have the word function. So this function also works just like add does, except we're using the keyword function. We're not creating an arrow function. We're using the curly brace here just after the number type, but it works in the same way. And notice both of these functions actually have the same type signature here. They both accept 2 number parameters and they return a number. So this is where it could be useful to use a type, especially if I know I'm going to create more math functions. Now actually I would want to create the type above both of these if I were to use it in these functions, but I'm going to create it below and then just use it for another math function. So I'll say type, and then I want to say math function. And then after that, I'm going to say it equals a function with a parameter that is a number. Need to type number correctly, and a second parameter that is also a number, and then it's going to return a number. So there is our definition for our math function type. And now if we were to create another math function, such as multiply, we could use this type. So I'll just say let multiply, and just right away I'll say this is a math function type. And then let's set this equal to a function, and it has C and D as parameters. And then I'm going to use the curly brace, and inside of the function I'm going to return C times D. And now TypeScript says this is okay. So let's mouse over multiply, and you can see the type it is assigned is math function, which is an alias for this type definition that we put up here that has 2 number parameters and returns a number. So now it should know our function is going to return a number, and it expects the first and the second parameters to also be numbers. So it infers that actually because we assigned this type alias to multiply. So it expects math function to match. So now I'll do one more log message, and we'll call our multiply function, and I'll say 2 times 2. And when we save, we should get 4 in the console, and we do. I'll make the console just a little bigger there so we can really see that text too. Now, when it comes to functions, I like to use the type aliases more than I do an interface, but I do feel obligated to show that an interface is also an option with a function signature, just like a type alias is. So I'm going to copy this down with Shift, Alt, and the down arrow once again. I'll just comment out the type above for a moment. And now I'll set this instead of a type to an interface. But we once again have to change some things for an interface to work. So we need to remove the equal sign and put a curly brace to start. Then I'm going to bring this down onto another line. And then I'll put a curly brace to end. But notice TypeScript still doesn't like the arrow here. We need to remove this arrow function, and we need to put in a colon right there. So this is an interface for math function, And when I save, TypeScript compiles, and we still get the same result here in the console. So this also works. But typically when I think of interfaces, I'm thinking more about classes and being able to extend those, which we'll learn about in the future. And then when I'm thinking of functions and other basic types, I'm thinking of type aliases. So what I'm going to do is uncomment this type and then comment out the interface, but leave it in there for you just so you can see both examples in the source code for this lesson. We're not quite finished with functions yet because I want to cover optional parameters and default values as well. So let's first look at optional parameters for our functions. So I'm going to define one more function. I'll call it add all, and I'll set this equal to a function that receives a number parameter and a second number parameter and a third number parameter. This is an arrow function as well. And then after that, we're going to say return A plus, need the plus, B plus C. So that would add all three of those. Now we didn't say what the return type was. That should also be a number here as well. There is our add all function. Now that's fine when we require all three of those, but we can say a parameter is optional by putting a question mark before the colon. And now we have a problem here in TypeScript. TypeScript put a little red line under our C, and if I mouse over, it says this is possibly undefined. Look at the type of the C parameter. It's not just number, although we said it was. It's number or possibly undefined because it's optional. So for TypeScript to be okay with this, we have to put in what is called a type guard. And a type guard narrows down the type of value assigned to the variable. So what we'll say here is if type of, and then we can say C is not equal to undefined, then we're going to return A plus B plus C. So I just need to put that inside. But TypeScript probably still won't be happy with the function because that's not the only possible result. And notice here we have a red line under number. It says the function lacks an ending return statement, and the return type does not include undefined. So it's not good if we just leave it like that. So essentially we need an else, but instead of an else, I'm just going to put a return here as well, because if it's not this, it's going to return the other, and I'll just say return A plus B. And let's see if TypeScript is now happy. And yes, it is. So if type C is not equal to undefined, it's going to return the sum of all three parameters. Otherwise, if type C is undefined, it's just going to return the sum of A and B. Now, I believe I mentioned it, but remember that if you have an optional parameter, it needs to be the last in the list. Your required parameters do need to come first. So now I'm going to copy this down. I'll just highlight all of this and do Shift-Alt and the down arrow, and then I'll change the name of the function, and I'll just call it SumAll, which means essentially the same thing. And here we currently have the same signature, number, number, and a third optional number. Well, let's change that to where this number is not optional, but really it still kind of is, because we're going to assign a default value now. So if we don't supply C, it will be equal to 2 if it is not explicitly supplied when the function is called. So C should never be undefined at this point. So we could go ahead and remove the if statement, and now we should be able to just put plus C once again, and TypeScript is okay with this function. So let's log some of these out with our log message function, and I'm going to say add all, and I'll put 2 and 3 and 2, so we should get 7 there. And I'll copy this down and add all again, and I will not supply the ending parameter for C, and there we should get 5 because the type of C will be undefined, so it should just add A and B. Now, for the last one, we'll do the SumAll, and I'll once again pass in 2 and 3, but we should once again get the value that we get for the first add all, which should be 7, because C should be equal to 2. So now I'll save all three of these, and yes, we got 7, and then 5, and then 7 once again. Now, unlike the rule we had for optional parameters, and I should put default param value here, C is the last in the line as far as the parameters here, but we could give A a default parameter. So I'll give this an equals 2 as well. And then if we were to call this and omit A, we would have to explicitly pass undefined in, because otherwise it would be assigned A. So I know that's a little bit confusing, but what we would have to do here, and I should make that a different number. Let's make it something obvious like 10. So instead of the sum all we have at the end with 2 and 3, I would have to explicitly say undefined, and that would be okay. Otherwise, if we do this, TypeScript doesn't like it because 3 is being assigned to A. It's the first thing in. So if you want it to skip over A, you have to give it a value there. So we'll say undefined and 3, and this would be rather obvious now that it should be 15. And that is because we have a 10 as a default value, and then we passed in the number 3, so that's 13. And then even though we didn't pass in C, it also has a default value of 2, so that all adds up to 15. Now, if you remember our math function above that we defined with an alias, type math function, and this is the function signature, we cannot do that with default values. So that is one thing that cannot be achieved with an alias type or also the interface math function here. Default values will not work when we define a function signature like this. Okay, I'm going to scroll up for a little more room as we're not quite finished with functions yet. We need to talk about rest parameters. And they look very much like the spread operator, but it's when we pass them in as parameters to a function. So I'm going to define another function called total. And this is going to be equal to a function that accepts a number for the first parameter. No, you know what? I'll leave out the first parameter at first, and I'll just say it's going to receive nums. And notice I'm using a rest operator there for nums, and then it is number, and it should be an array. So that represents an array full of numbers. We don't even know how many numbers, but that's what we have. And then this function is going to return a number. And then inside the function, I'm going to return, and then I'm going to use the nums array that is passed in. I'm going to call reduce on the array because it's a good function for totaling up an array of numbers. And now inside of reduce, we'll have the previous value and the current value represented. And then we just arrow over and say previous plus current. And now that we've done that, our function is complete. So let's look at what happens when we use log message and then we call total. And we're going to have 1, 2, 3, and 4 all passed in. Now again, notice I'm not putting an array here, but this is represented as an array here because we used the rest operator. So when I save, we get the total of 10 over here, which 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. That is correct. So the reason this is called rest, if you're not familiar with it, it kind of means the rest of the parameters. So this should always come at the end as well. So if I were to represent this with another parameter first, like I almost did in the beginning, I could say A is a number, it's required, and then however many other numbers I want to pass in. So I could just pass in 2 values, say 1 and 2, and save. And now, of course, we get 2 over here at the bottom. And that's because I didn't use the A parameter. Notice it is still a little lighter here. So let's now say A plus whatever we reduce from this rest params, which is the array, and I save. Now we get 3. So it took whatever I passed in the beginning for A, and then however many numbers remain, and it represents those as an array. So now we could say 1, 2, 3, and save, and yes, we get 6. Or if we changed 1 to a 10, then we're going to get 10 plus however many other numbers there are. So once again, to emphasize this, the rest operator here for the rest of the parameters should come at the end. All of your other required ones should come at the beginning, and this represents the rest, which will be represented as an array inside of your function, but not when you pass the parameters in. You might also be wondering why I didn't assign the specific types to previous. And if we mouse over, you can see previous is a number. We mouse over current, it's also a number. And if we mouse over reduce, we're going to get a bigger definition, but you can see it returns a number as specified right there. Well, we're already declaring what is being passed in and what will be returned from total. So TypeScript can easily infer that these should be numbers because we've already specified that above. Okay, now that we have learned more about functions, it's a good time to cover the never type, which is a basic type, but you don't see it that often, and there are a few instances where you may need it, but if you were not aware of it, it would definitely surprise you. So let's go ahead and create a function, and I'll call this function create error. And then inside of this, I'm going to say error message, and it's going to be a string. And I'm not going to define the type here. I'll just let TypeScript infer it, because we're going to throw a new error, and we'll just pass in our error message. So now if I mouse over create error, we can see it returns the never type. And this is essentially for functions that explicitly throw errors. So if we were to explicitly put the type here, we could with never, and it should look the same when we mouse over, and it sure does. Now, it will also be a never type or a never return type from a function if that function has an infinite or endless loop inside. So I'll just say const infinite. I'll set this equal to a function that doesn't even accept any parameters. Here I'll say let I, and it's a number, we'll assign 1. Then I'm going to say while true. Inside the loop, I'll just say I plus plus. And now, if I were to mouse over infinite and look at the return type, it's never, because this is an endless loop. We wouldn't want this. So overall, if you're having TypeScript help you and you look at what is being inferred and you see never, make sure you want to throw an error. If not, you probably have a problem like an endless loop inside of your function. So how could we solve this? Well, let's go ahead and put in if I is greater than 100, then we'll just use a break. So now let's see what the return type is for infinite. Now it's void. There is no explicit return, but that is much better than the never type where we would have created an endless loop. So I'm not going to comment out this if statement because I do not want to leave an endless loop in your code. However, just remember that that's what this is about right here. So it's currently, as I'm going to leave it, the return type is void. But if this were not here and you had an endless loop, it would be a never type. So when could this never type actually be useful? Well, let's look at how TypeScript thinks about things. So I'm going to say const and create number or string. And this is just going to be a function that identifies a number or a string. So inside of here, I'm going to have a parameter named value, and it's a union type that could be a number or a string when it's passed in. And we're going to return a string. And I'll make this an arrow function. Now we'll say if type of value is string, then we're going to return the word string. And then also we can say if type of value equals number, then let's just return the word number. And now you would think that would be it because we can only pass in a number or a string according to what we have assigned here. And we're always returning a string, but TypeScript still does not like what we have defined. So let's look at what's going on when I mouse over. It says the function lacks an ending return statement, and the return type does not include undefined. So how could we solve this? In normal JavaScript, just vanilla JavaScript, we might just have an empty return. But TypeScript is not like that either. When we mouse over, type undefined is not assignable to type string. This function needs to return a string as we have specified here. But what we can do is return our create error, and we just pass in a message like this should never happen because it's essentially the never type. And now TypeScript seems okay. So when we mouse over, We've got a value, number, string, and returning a string, and TypeScript is great with all that because here we're returning a never type. So essentially we've used type guards here to check the type of our value, whether it is a string or number, and we know this should never happen, but essentially TypeScript needs that explicit return yet with a possible error when we do not have, when we'll go ahead and remove this and look at the specific message it gave, when we do not have an explicit return and it's not handling a potential undefined. So I'll remove these comments and TypeScript should once again be happy. But now if we're using these type guards like type of value is number or type of value is string many times in our code, we might want to create a custom type guard for that. So I'm going to define it above and I'll just say const is number, and I'll set this equal to a function that accepts a value, and I'm going to set it equal to any here. But we want a Boolean return type. And now inside of the function, I'm going to return type of, and we'll have value equals number, and I'm going to use a ternary statement here. So if that is true, we'll return true. Else, we'll return false, because that's what we need to return for this function. It's a Boolean type. So overall, we're looking at whatever values passed in, and if it's type of number, true, anything else is false. So here, instead of our type of value equaling number, we could just say is number value and have the same result. So this created a custom type guard that we can use. So I'll quickly annotate these. This would be a use of the never type. And up above, we'll just call this a custom type guard. And now we have covered functions, literal types, type aliases, and of course the never type. Remember to keep striving for progress over perfection. And a little progress every day will go a very long way. Please give this video a like if it's helped you. And thank you for watching and subscribing. You're helping my channel grow. Have a great day, and let's write more code together very soon.